Welcome to today's lesson on frequency distribution tables. In this session, we'll explore how to summarize data using frequency distribution tables, the key components involved, and the methods for organizing and interpreting data effectively. Let's dive in. What is a frequency distribution table? A frequency distribution table is a way of summarizing data by showing how many observations fall into different categories or classes. It's an essential tool for organizing data in a way that makes it easier to interpret and analyze. Throughout this lesson, we'll go through step-by-step processes to build one from scratch. Let's take a look at our example dataset. These are the heights of randomly selected students enrolled in BSEC, measured in centimeters. Our goal is to construct a frequency distribution table based on these heights. You can see the raw data here, and in the next few steps, we'll organize this into a more understandable format. Our first step is to arrange the data, either from lowest to highest or highest to lowest. For simplicity, we'll arrange it from lowest to highest. This helps us see the range and prepare for grouping the data into class intervals. Pause here and organize the data in ascending order if you haven't done so already. It's an important step that simplifies the process later on. Next, we calculate the range, which is the difference between the highest and lowest values in the dataset. The formula is straightforward. Range equals the highest value minus the lowest value. In this case, the highest value is 177 centimeters and the lowest is 149 centimeters, giving us a range of 28 centimeters. The next step is to determine the class interval. To determine the number of classes, k, we use Sturge's formula, which is equals 1 plus 3.322 times log n. In this formula, n represents the total number of data points, and we use the logarithm of n to help calculate the number of classes needed. Let's apply this to our dataset. If we have 30 data points, we first take the log of 30, which is approximately 1.477. Now, plugging this into the formula, we get k equals 1 plus 3.322 times 1.477 is equal to 5.907. We round up to the nearest whole number, so the number of classes is 6. To finalize the class width, we use the formula class width equals range divided by the class interval. We already know the range is 28, and for this example, we'll use 6 classes. Dividing 28 by 6 gives us a class interval of approximately 4.67. Since we prefer whole numbers for simplicity, we'll round it to 5. This means each class will cover a span of 5 units, ensuring our data is evenly distributed across the table. Let's move on to setting the class limits and boundaries. Class limits define the smallest and largest values within each interval. For example, if our first class starts at 149, to determine the next class limits, subtract 1 from the class width, which is 5 minus 1 gives us 4, and then add it in the first class, which is 149, which is 149 plus 4 give us 153. To complete the class limits, you need to add multiple of the class width until you obtain a value greater than or equal to the highest value. For lower class limits, 149 plus 5 is equal to 154. 154 plus 5 is equal to 159. 159 plus 5 is equal to 164. 164 plus 5 is equal to 169. 169 plus 5 is equal to 174. For upper class limits, 153 plus 5 is equal to 158. 158 plus 5 is equal to 163. 163 plus 5 is equal to 168. 168 plus 5 is equal to 173. 173 plus 5 is equal to 178. Since we already obtained a value of 178, which is greater than the highest value in the example, that ends the computation for class limits. Next is the class boundaries. The class boundaries are more precise expression of the class interval. It is usually one significant digit more than the class limit. To determine the lower class boundaries, you need to subtract 0.5 to each of the data from lower class limits, and to determine upper class boundaries, you need to add 0.5 to each of the data from upper class limits. That is 149 minus 0.5 gives us 148.5, and 153 plus 0.5 gives us 153.5. Apply this computation to all data from the class limits to complete the class boundaries. You may pause the video and do the calculations. Now that we've set up the class limits and boundaries, we can start building our frequency distribution table. We'll tally how many data points fall within each class and record the frequency, class marks, and cumulative frequency. Let's begin by filling in the table. For the first tally, we have 149, 149, 151, 152, 152, 152, and 152 falls in the range 149 to 153. Counting them give us 7. Encode the numerical count in the frequency column and tally count in the tall column. You may pause here and start tallying the frequencies for each class. Once you've tallied the data, the next step is to calculate the class mark for each interval. The class mark, also known as the midpoint, is the average of the upper and lower class limits. To calculate it, simply add the upper and lower class limits together, then divide by 2. Class mark equals 149 plus 153 all over 2 give us 151. Apply it to each of the data to complete the class mark. You may pause the video to calculate them all. Alright, now that are done completing the class mark, we can now compute for fx, which is the product of the class mark and frequency. That is, 7 multiplied by 151 is equal to 1057. 3 multiplied by 156 is equal to 468. 9 multiplied by 161 is equal to 1449. 2 multiplied by 166 is equal to 332. 7 multiplied by 171 is equal to 1197. 7 multiplied by 176 is equal to 352. Next is the last part to complete the frequency distribution table. The cumulative frequency, it is the number of observations that has been accumulated either from the highest class interval to the lower class interval as in the greater than cumulative frequency, and if on the reverse order starting from the lowest class interval, it is called the less than cumulative frequency. To calculate for the less than cumulative frequency, just copy the first frequency, which is 7, then add the preceding frequency, which is 3, and give us 10. To determine the next less than cumulative frequency, just add the previous result, which 10 to the frequency next to 3, which is 9, and that give us 19. Then, 19 plus 2 give us 21. Continue the pattern to complete the column for less than cumulative frequency. Now, for greater than cumulative frequency, we start from the bottom by copying the frequency align with that row, which is 2, then add the next frequency above to that data, which is 7, give us 9. To determine the next greater than cumulative frequency, just add the previous result, which 9 to the frequency above 7, which is 2, and that give us 11. Then, 11 plus 9 give us 20. Continue the pattern to complete the column for greater than cumulative frequency. Here's the completed frequency distribution table with the frequencies, class marks, and cumulative frequencies filled in. Notice how the class marks give us a representative value for each class, and the cumulative frequency tells us how many observations have been accounted for up to each point. Now that we've completed the table, let's think about its practical uses. Frequency distribution tables make large datasets easier to interpret by organizing data into manageable categories. This helps us quickly identify patterns, such as which class interval has the most observations, or how data is distributed across different ranges. Let's take this a step further by analyzing the data. We can use the frequency distribution table to find measures of central tendency, such as the mean or median, and understand the spread of the data. The class marks and frequencies play an essential role in these calculations. That brings us to the end of today's lesson. You've now learned how to construct and interpret frequency distribution tables, and you've practiced organizing data into classes. In the next lesson, we'll dive deeper into how to use these tables to calculate measures of central tendency and dispersion. Thank you for watching this video on Math and Phil Tech TV. We hope you found it informative and engaging. If you enjoyed the content, please give it a thumbs up and don't forget to subscribe to our channel for more videos like this. Hit the notification bell so you never miss an update and share this video with your friends and fellow learners. Your support helps us continue to create great content. See you in the next video.